All right. Well, hey everybody. Doing a driving to a meeting here, and I figured I would do a little update because I was just on a Bardwell chat on his Patreon, and I was surprised at the questions that people had. So I figured I would jump on and just see if I can provide some 2 cents while I'm driving. So I only have about 40 minutes. Hopefully it doesn't go longer than that. But anyways, so on this chat there was the Helio drama. There's been some 32K stuff I've been looking at, and there's some stuff going on with Betaflight 4.0 for the RPM notch low pass filters. On this Barbell chat, some people had some questions, and he addressed them very well. And I didn't, I try not to chime in too much because it's his thing. But I guess one of the things that I don't see covered too much out there, I figured I could provide some insight was, I would say, for my 2 cents, if you're buying any ESCs nowadays, to make sure you're buying 32-bit ESCs. Specifically, first of all, there's settings in there. Bardwell did a great interview with Ryan Harold. Some settings in there to make your motor smoother. So that's across any firmware. PWM frequency up to 48. I learned stuff in there as well. So go check those out. Second, with Betaflight 4.0, there's going to be some RPM notch filters that Joe Lucid's working on. That's going to work on telemetry. It's actually, you don't need the telemetry pads, but from your ESCs, but it will backfeed telemetry of the RPM of the ESCs to your flight controller and control where the notch is going to go. As of right now, those are going to need 32-bit ESCs. They are working on seeing if they can make that work for Helio ESCs, but there's no guarantees, on that yet. So there's 2 reasons. So if you don't fly Betaflight 4.0 or Betaflight at all, still I would get 32-bit. So I think that's a pretty safe bet for good advice. I guess to hit the Helio thing, after the 25th, I guess their settlement is closed after the 25th, so who really knows what's going to happen after then. And, we'll see where it goes from there. I would assume they're going to reappear, honestly. That's what my bet is. Who knows if they're going to keep updating firmware or not. But one of the questions that people have is, will Betaflight, Helio is not just Butterflight, right? You can fly Betaflight on a Helio, but it's not supported by the Betaflight devs. I can't speak for the devs. I'm not in the inner circle of the devs or anything. I hang out in Slack. But just from what I've seen, there's no way they're ever gonna, in my humble opinion, make a target for the Helio or support any of that. But the firmware's out there. You could integrate the target yourself, or somebody else could. The IMUF is a whole separate thing. I believe that it's separate. So even if Helio doesn't update the IMUF, you should be able to keep going on the other firmware. So I know, and that irks me because that's me saying that. So I think there's stuff that you can definitely do to keep the life of that board going. But that aside, just keep in mind there was a lot of questions that I saw that I believe the IMUF is totally separate from the firmware that runs the board. So that, or you can, get another board, so on and so forth. Barbara was giving us some good advice on that if you just got a board. And I think Flight 1's looking into some stuff as well. Some people were asking, what board should I get? And, I would go to these other experts. I'm not an expert on boards, but I guess my 2 cents is I would definitely get an F7. After just getting onto FR Sky, this whole inversion thing, if you haven't dealt with it, you don't want to, just get an F7, you don't have to deal with it. They're not that much more expensive. And the additional UARTs, now that we're getting into GPS stuff, I think it's definitely worth an F7. The other topic that I've been looking at is this 32K sampling versus 8K. So I've been running some tests, and it started with this sensor fusion boards. I think I would say pretty common thing is that sensor fusion is, there's basically two gyros on the same flight controller. One's rotated 90 degrees to the other, and they combine the signal. They average the signal together. So if one's saying it's rotating at this rate, and the other one's saying it's rotated, they're never going to actually purely match the same rotational rates. It averages that together, and that's what it sends to the PID loop. Throws it through the exact same filtering. So a lot of people notice, and I've noticed as well, and I have data to show it, that in 32K, and I posted this on my Facebook page, UAV Tech Facebook page, so go check out that post. There's lots of other good posts there too, if you're kind of posting between videos there. So, and the data's up there and you can download it, but it looked like what it's showing so far, and I want to do some more testing, is that in 32K, the differential between the gyros was more. So for any given gyro, ICM, InvenSense ICM gyro, which all the boards use except for Radix, the measurement differential from one gyro to the next, there's a wider spread when you're in 32K mode than in 8K mode. So in 8K mode, the output of each of the gyros, which is the exact same gyro, was tighter. It's almost like the precision. Would that be precision? Accuracy, precision. I think it's precision. Accuracy is different. I think the precision, I'm going to go with that, is tighter in 8K mode. So you're more liable to get a more precise answer from any given gyro. The sensor fusion kind of adjusts for that, but it begs the question is, why is that? Why in 32K mode does the InvenSense gyro give less precision or more varied readings? So long story short is some more testing needs done on that. It was only one gyro, or one board. It was only one gyro chip type, which was the ICM 2689, which is I think it's a fairly new gyro chip. But it's the product use is actually listed as drone. Like drone is one of the product uses, where the normal, the 2602, I think that was really developed before drones were a big thing. So I have another sensor fusion board that does have the 2602 chip, gyro chip from InvenSense. So let's see if that gives the same result. I'm gonna surmise that it will, because other people have done this testing and they've noticed that sensor fusion is more useful in 32K mode than in K mode. I think it's useful in general. It does give you a more precise answer. But yeah. And if you're making comments for me to read, I'm not, because I'm watching the road. So forgive me for that. I'll look back through them later. So that's just the two things I wanted to kind of get off my mind. Is first, I guess, make sure you're getting 32-bit ESCs. The RPM notches, basically, instead of the notch filters, the dynamic notch will still be there, and that reads the actual noise, the vibration, and updates, but that takes time for it to do that. Where the RPM notches gets the real-time RPM, doing an amazing job on pulling that together. I mean, my hat's off to him, and everybody's been testing it. For him to do this, he's working between the Betaflight team and also the BL Heli guys, and just that cross collaboration, that's no simple thing. So yeah, it's still under development. Or if I had to guess, it's probably only going to work on 32-bit, but maybe not. And it's showing some real good promise. Notch filters are more effective, in my opinion, of Kelsey. And it's not really just my opinion, it's just data. I mean, my opinion's based on looking at the data. So I really shouldn't say my opinion, because They're used really well in this hobby. Second thing is, if you have a Helio, firmware is out there. The open source stuff could be updated, but the IMU, unless that company, because that's proprietary code, releases that or whatever, somebody could carry the ball on that. I would not count on Betaflight doing it. And honestly, I've run the tests. I don't see anything special in the IMU data. I know people will be arguing with me, but they don't have, I guess I'm making my conclusion based on the test I've run, which I have the data out there. You can check out yourself. So why hold on so tight to this thing? I don't know why, but if you do want to, somebody could carry the ball on that. Programming to update the source code, because the Betaflight source is updated quite a bit. So that's some options there, and let's just see what happens after the 25th anyways. And then, I guess that's kind of what I had. So hopefully this, I guess we're at about 11 minutes here. I'm doing pretty good. I'll try to read back through the comments and address questions if we get officially. Yeah, 32K on 4.0 was officially removed. Yeah, I read the comments. Shouldn't have done that. Had nothing to do with this gyro spread thing that I was looking at. That's just been a couple years in the making, at least a year. There's a lot of people have tried it, and it just doesn't work out. It generates a lot of noise when you go to 32K sampling. It should be dropping off about 0.88 milliseconds of phase delay, which is, in filtering, it has nothing to do with processing speed. It's just by it running through the filter, it offsets the signal in time. Bardwell did a really good example of that in his last video, so check that out with the 10 sample averaging. That 10 sample averaging that he uses in that video, that's exactly what a FIR filter is, a finite impulse response. So a FIR filter type, like I said, finite impulse response means after the samples stop coming, the impulse response stops, because it's, after the averaging of samples after the samples stop coming in, there's nothing else to average, it stops. Or a infinite impulse response, an IIR filter, which is what we use, like the PT1, the frequency filter, the biquad filters, the FKF, any Coleman stuff, any of that stuff, that's all an IIR filter. So that's an infinite impulse response, meaning that it uses the data, smooths it, and then uses the past data to predict the future step. So even if data is not coming in, you'll always have one past data sample that's used to smooth the incoming step. So it's infinite impulse response. Now obviously it goes to zero, to absolutely nothing when the data stops coming in. But nevertheless, almost all filters are infinite impulse response that we use. The finite impulse response, the FIR filters, which Betaflight used to have one, they just have too much phase delay associated with them. So there's a little tidbit on that. So when you hear of all these filters, they all boil down to IIR filter types, infinite impulse response. And it's just really what can produce the most amount of attenuation for the least amount of phase delay, which is shifting the signal off in time. So that's what that is. Is there any other question-y things? I don't see any. Getting out of a traffic jam, that's great. All right. So again, the 32K thing will be removed. Honestly, it's not that hard. I have seen some questions where people say, yeah, what if a new gyro comes out? Isn't that short-sighted? And it's like, well, it could be added back in. It's not that much code. So that could be, the 32K could be put back in. And that, obviously, it's a Betaflight dev choice, not mine. But I saw the pull request to pull it out, and it's not that much code. I would say it's 30, 40 lines, 50 lines or more, I don't know. But, and it's in different files and all that stuff. But to me, this this stuff, I'm really intrigued by the stuff where the signal gap, the precision wasn't as tight, because that has ramifications regardless of firmware. I know, you know, talking with Preston, he's like, well, we get, you know, we're getting better data off of our 32K sampling, and I can respect that. But I can't, you know, ignore the data that I'm seeing from the logging results from these two gyros. So we'll vet it out and see how it hopefully progresses things moving forward. Okay, well, I think I'm out of stuff to talk about. Hopefully this was somewhat helpful. If you have questions, don't hesitate to hop over to the Facebook page and just private message the page or whatever. And I'll try to help out as much as I can. Like I said, hope this helps some, and thanks everybody. Happy flying. Let's see if I can do you know what exactly sim mode is in the flight? Now, I don't know what sim mode is, and no, you know, I can't get Flight 1 logging to work for me. Now, I switched from Spectrum because I was getting fail-safes like crazy. So that's another thing. If you're on Spectrum, don't use their satellite receivers. The 3-volt ones, I switched over. I don't know. They just, when it gets cold, they sucked. I couldn't take it anymore. So I switched over to FR Sky. I'm hoping I can get logging to working. I don't know what sim mode is, but with all due, you know, I love Preston. I love Flight 1. When he says they're a family, that's totally true. I see the support they give. Some of the stuff with the sim mode, you use the PIDs to tune it, but it's not a PID controller. You got to use filtering so the noise doesn't get crazy, but there's no D-term. I mean, it might be a variant on the PID controller, but if you have PIDs to tune it, and there's still noise from D-term oscillation stuff and P-term vibrations, you know, I mean, come on. It looks like a duck, sounds like a duck. It's a duck. So I'm not saying there's not a variant on it that they have in the secret sauce there, but I really do think it's just a PID controller, to be honest. I don't have any logs on it. Would love to log it. Honestly, he asked me a while ago to help, you know, pull some clarity on their filtering, you know, to give some videos on their filtering and look at that. And the roadblock I hit, and I really feel bad about it, and I've been trying to do my best with it, with the frequency or the filter fundamentals, is to, you know, talk about how you can adjust your filters in Flight 1, but without logging it, you're guessing a lot. I really feel like you need logging. I ran into a roadblock because I couldn't log. I was hoping to be able to log and kind of get into the weeds on it. Now, there's some thing around where if you have a Spectrum, it doesn't work really. Logging can get goofed up. So hopefully now with this FR Sky, it will work. I'm not sure if other people have the problems or not. Yeah, I tried setting it to latency mode and all kinds of other stuff. I've flashed the back box and all kinds of, you know, I've spent hours on it. Be a break, Kebab said drop 20 at the time will help. I don't know what that means. Sim mode. So yeah, if there's any magic sauce to people knowing how to exactly get, what about 1K? Okay, so 1K. So one of the Betaflight devs did some filter analysis in Octave. So Octave is like MATLAB. And MATLAB is a software used to basically do math, but you can do some amazing stuff in MATLAB, but you got to pay for it. Octave is free. It's probably not as amazing, but it's still pretty amazing. And you can model the exact code in Octave and then run it through different. And I have the code. I actually posted it up on the Facebook page. So I have it's not the last post, the post prior to that. Whereas as you go down in frequency, the biquad filter appears. The Octave's code's there, so if you want to challenge it, go look at it. See, tell us if we're doing something wrong. That as you go down in frequency, sampling frequency, the filter becomes more effective. The phase delay doesn't go up, but the attenuation gets steeper right at the Nyquist limit. Now, dihertz, another Betaflight dev. He's not as active as he used to be, honestly, because of the Helio thing, which I that people realize that. Like 2 devs quit because of that debacle, because they just got fed up. So that's why I was so passionate against some of this trash talk. It's like, guys, you're discouraging volunteers that I really appreciate advancing the ball on this hobby, and you're using their software to fly your board. So how about you stop doing that? Anyways, he did some testing as well on it and found that right at the Nyquist limit, the filter attenuation spikes, or on a bode plot, it kind of drops down. It shows how it attenuates more. So anyways, same things happening for the, that was for the PT1, same things happening for the biquad. And the trick is to get, at 1K sampling, your Nyquist limit is down at 500 hertz. But also you have noise at that limit too. So you can start to get aliasing. I've run right now in Betaflight, run the dynamic notch, anything below 2K. I have some code that it's only like 33K, and I've run that at 1K. It doesn't work, and if you have the dynamic notch enabled. But I have run, honestly, I don't even know if you need the dynamic notch down at 1K, because that biquad is so steep at 500 hertz that it's cutting out a lot of the noise from 500 down to like 300. And that's where, when you're on a 5-inch quad, around your peak motor noise around 250 hertz when you're like just cruising forward. But whenever you're getting on the throttle a little bit, like 50%, 60% throttle, you're up in like the 300, 400, 500 hertz range for your peak noise for a normal 5-inch quad. For a micro, it's going to be even higher than that. It's getting a little hot in here. But anyways, I'm pretty sure. Yep. Hopefully I've connected again. So anyways, there's actually a channel on the Betaflight Slack where we are looking at lower sampling frequencies. And Bruce, E-Tracer, which is one of the main devs, basically said, hey, you have that dual FC rig. Why can't you put, run one at, whatever, 8K and then run one at 1K? Let's get the same input. It's basically the same input data, see what the output differentials. I just haven't run it yet. It's winter here, it's always snow when it's cold, busy, that kind of stuff. I got all the excuses in the world, right? But that's being looked at. The filtering's more effective down low. It just is aliasing. In fundamental, aliasing should be a concern, and it should, but honestly, when I've flown at 1.33, I didn't notice anything weird, so I wouldn't think at 1K it's going to be any worse. But yeah, but you can't run the dynamic. So I mean, give it a shot yourself. Run a log at, run some flights at 4K or 8K. With the RPM filter, by the way, it's not going to really run above. It will run at 8K, but I'll do a video on this. You have to actually go into the type status at the command line and make sure your PID loop's actually getting completed, like actually running the full PID loop. The other thing I like to do is run tasks. It's at the command line, TASKS, enter. And then you can look at your PID loop and see how much percentage that's actually using. A lot of times you'll be like at 20%, but you look at the PID loop, it'll be like 110%. So you got to look at those two things. So the percentage at the, I don't know, I've seen it said so many times that the percentage in the GUI at the bottom, that it's garbage. I've seen it from devs, and I don't understand why it's there then. Just get rid of it. But maybe there's something I just don't understand. So definitely I'd run status and tasks to see what your real percentages are of stuff. But anyways, so RPM is going to be at 4K anyways. Most likely maybe get up to 8K, and they might optimize it. Usually new software at first comes out, and then you go back and refactor it and try to optimize the code later. Or different people look at it. It's that kind of stuff. So do some tests at that in the normal Betaflight, and then go ahead and do some 1K, see what you think. Do you think your opinion on this is official release for will be reliable enough for attenuation without yes. At 8K, you are not going to need, you should not need stage 2 filters on 8K or 8K mode in general. And you'll hear me say a lot of 8K mode versus 32. The gyro, any gyro chip only has, except for the Bosch is a little different. And that only goes up to 3K anyways, so it's not like it has all these big ranges. But a normal ICM gyro has 3 modes. That's it. 1K, 8K, and 32K mode. So whenever you're switching up, that's why the 32K is a checkbox, or was a checkbox, because it switched it into that other mode. Betaflight is always an 8K mode. Unless that before with that checkbox was there. If you wanted to go to 1K mode, you have to go to the CLI, and if you type get gyro, you could set it to 1K mode. And then, so even if you were at 8K like say you're sampling at 4K, well, you're not actually sampling at 4K. The gyro is actually sampling the analog, which is the actual motion and actual vibrations. It's digitalizing that at 8K, period. At 4K gyro rate, that means it's just grabbing every other sample. At 2K, it's grabbing every 4th sample. And then it's feeding, it's feeding that through the filters, and then that goes off to the PID loop. So, again, at 1K, when I was running these 1K logs, that showed that more effective, because it was running the filtering at a 1K loop rate. And at a 1K, running the filtering at that loop rate made them more effective. And that's what also this octave shows, and the beta and the logs show the same thing. So you got 2 sources of data showing the same result. That's how science works, right? Now, what's better than that? 3 sources, 4 sources. The more sources you can get, the better. So you got 2 sources. The same thing with this variance I'm talking about with the 32K mode versus the 8K. That variance, I got 1 source of data showing me this. That a couple ways. One of the guys on the comments did some peer review on it. Was asking me some tough questions, which is good. I think I addressed all his questions and concerns. I want to look at it with another board, another set of gyro chips. But so to truly get 1K, you'd have to set the gyro to 1K. Now I think the downside is the digital low pass filter inside the gyro, the latency goes up there. But hey, maybe then that's all the filtering you would need at all. You wouldn't need any of this other filtering. So I haven't honestly tried it. Shot. If you first do a baseline on the same rig. That's the other thing. Whenever you're doing this stuff, it has to be the same rig, same props, all that kind of stuff. If you crash and you have to put on a new set of props, sorry, you got to do your baseline again. Like, you can't have this variation. It's too many factors are changing. So if you do a baseline on whatever, 4K, 8K, and then you try this 1K and you have some interesting data, love to see it. I'll feature it on the channel, whatever. I haven't done it yet. The stuff I've put up so far, the gyro is actually in 8K mode. We're just downsampling it to 1K and running the filtering at a 1K. The filtering is more effective there. So I think there's something there. I mean, I kind of say sometimes in the Slack, like, KISS is sitting back just laughing at us as we're going through these iterations. Have you heard through? Can't wait to see that. Yeah, I want to do more on Flight 1 filtering. I really want to get logging. I really need logging to work, because I want to show you data. I don't want to just, I mean, I think people do it through feel, but that's so hard to convey. You need a lot of experience, a lot of time. Whereas I think if you look at the data, you can go A to B to C and be done, and know that you're done because you can see it. You can see it in the data. I do get that with sometimes with the, oh, I don't go by black box. I don't like black box. I just go by how the video looks, and I can respect the video. There's nothing wrong with that approach, but I want to make sure that people don't discount black box logs. A video at best is 60 frames per second. 60. I run my black box logs at 4,000 frames per second. So there's going to be stuff that the log is going to show you that the video won't. And the log is definitely, if it's in the video, it's definitely in the log. So logging is really how you really engineer or hone in on, the details for a precise answer. See if I can see something. At 16K, yes, you are still, the gyro chip is sampling at 32K, the analog. So there's an analog vibration. Analog means it's like the real vibration of the motors and stuff. It's digitalizing that, so it's taking a sample every 0.000325 seconds. And then at 16K, you're just, Betaflight at least, is grabbing every other sample. In flight 1, I think it's 32, you can't pick the sampling rate. But in flight 1, from what I understand, and if Preston would comment and say otherwise, then obviously he would be correct and I would be wrong. But from what I understand through that, is that there's a gyro smoothing option. And if you turn on gyro smoothing, like it's above the filtering, that actually averages 2 samples. So if you turn on gyro smoothing, it's actually giving you 16K. It'd be like in Betaflight doing 16K. But in Betaflight, it does every other sample, whereas Flight 1 would average 2 samples together if you're turning on gyro smoothing. You can't pick 16K in Flight 1 that I've seen. So, yeah, you're either in 1K mode, 8K mode, or 32K mode. Now, that's an ICM gyro. If you're MPU 6000 gyro, there's either 1K or 8K. That's it. There is no 32K. And any savings, I guess the one thing, I put this on, it's, 0.01 milliseconds. Yeah, 0.01 milliseconds, I think it was, or 0.1, maybe it was 0.1, I don't know. I mean, just take 1 divided by 32,000, take 1 divided by 8,000, subtract the 2 differences. The difference in sampling rate and speed is really small when we're talking about phase delay from filtering being 1, 2, 3 milliseconds. And that phase delay shifts the entire signal off in time. Where sampling rate means, oh, well, I could miss the peak of the prop wash by 0.01 milliseconds or 0.1 milliseconds. Yeah, you could, or you could not. It could hit the peak right on. And, talking 0.1 milliseconds when you have milliseconds of phase delay, which shifts all the data off. Filtering delay is by far the most important thing that we need to worry about. So that's why my focus is so much on it, because it's critical. I mean, you can see it in logs, the raw data. After you filter it, everything's shifted off. But we have to filter it because the D term goes bonkers if you don't. So yeah, in 32K mode, 16K, every other sample, same thing. In 8K mode, if you're 6K or 4K, same thing. Another tip: always run at even with the dynamic notch. Always run at even sampling rates, like 2, 4. I wouldn't necessarily go 6. The dynamic notch, and this is a fundamentals thing. I don't have any data to show that this is, but the fundamental of it, the dynamic notch uses a fast Fourier transform to do a spectrograph of the noise. If you look into what a fast Fourier transform is, it needs to have even numbers for it to function mathematically properly. A Fourier transform can be any number, but it's a lot more it's a lot more intensive math and so on and so forth. So either way, the dynamic notch works at using a fast Fourier transform. So you want even numbers. So that throws now, I said I ran at 1.33K and everything seemed fine. It did. Fundamentally, though, if it's running a fast Fourier transform, it shouldn't. Is there something I'm missing? I didn't notice anything. It seemed to be fine. 0.33K. And there's a gentleman on here as well that's done some of this stuff with me. Quadfly X, and also Brian White's done some stuff. I think all 3 of us, and I don't think those two guys talk to each other, I don't believe, about this, but I swear my battery lasted a little bit longer. Like, I mean, like 10, 20, 30 seconds. We're only getting 3 minutes of flight. That's a big deal. And I swear it felt sharper, but it's worth your time to just fly it once. I mean, it's just a selector. You select it down, right? No big deal. Just take what I just said with a total grain of salt. I have no data to show. I did look at, there is some stuff that happened with the D term though. Since the D term, since there's less samples, instead of it rounding, like the D term's going up, right? Instead of it rounding to come back down and then go down the other direction to oppose, you know, prop wash movements or whatever, since there's less samples, it more goes up and then immediately starts to jerk down. So it felt like it had a sharper response to me. But, you know, that could be me. I don't put a lot of merit in that kind of stuff. I'll mention it, take it for a grain of salt. To me, that kind of thing is, okay, I think I'm noticing something. Let's look at the data. Is the data validate what I think I felt or saw? And if it doesn't, what I think I felt or saw was probably a placebo. So maybe what I just said is a placebo. And I wish with some of this other stuff we would integrate that into our thinking, that if you think you felt something, that's cool. If you don't have any data to back it up, it just could be placebo. There's a lot of placebo in humanity in general. I bring this up because one of the things that I've already talked to Bardwell about a little bit about this subject is, well, there's so many people that like these things. That has to be real. There has to be something if there's so many people. And I'd say there's some merit there. Maybe. But let's look at this on the other side. How many major religions are there in this world? And I don't want to get on too much of a sensitive topic, but there's at least 3 major ones or more, 5 maybe or something. Billions of people in each. They conflict with each other a lot. So at least a couple billion people are wrong, no matter how you slice it, no matter what. So just because it's a lot of people doesn't mean, I mean, it's a factor, but it doesn't mean, oh, it's got to be fact, it's a lot of people. Data is fact that's my humble opinion. You don't have to agree. It's just, I'm an engineer. I mean, that's how we operate. Let's see if I can peel off anything else. Getting on my the official release is April something. If you go to the GitHub page, fake filters, yeah. If you go to the GitHub page, I think it's, if you go under the PR, like you go to the Betaflight GitHub, you go to the PRs, and then under there's a button that says milestones. You can click on it, and it has the exact date. It'll say like April, I think it's April 12th. I don't know, don't quote me on it. Somebody could probably look it up real quick and post it here. Betaflight filter feels better than Betaflight 5. Could you say it isn't placebo, but I can't? There's a lot that's Betaflight 4 feels, yeah, well, there's a lot that's changed in 4 that is fun. Here's the other thing with the feel. I know talk a lot about filters for feel, like, oh, this filter makes it. I struggle with the filter being the difference. So when you start looking at OpenTX and your input signal, so apparently, and this is outside of I've been learning about this because I got an R9, I got some juicy information on R9 too. So I got an R9 with my Taranis, great deals that you can get at, I just couldn't pass it up. You got an R9 and a QX7S for 220 bucks and two R9mm receivers, 220 bucks all in. That's with the Super 8 antenna and everything, so I went for it. Crossfire is definitely better than R9. I'm not saying it's junk though, it's half the price, so that all evens out. The frame rate for an R9 is a little inconsistent. We'll talk about it. But anyways, learned, or somebody told me that apparently OpenTX, when you input the signal or your stick movements, OpenTX messes around with that for like 30 milliseconds or more before it gets out to the external modules. I have no idea if that's true or not. I don't want to make anybody mad if they're in that project, and if I'm wrong, show us data that says that's wrong. Then it goes into Betaflight in a bunch of frames. Depending on that frame rate, and if you use smoothing, whatever smoothing you do, at least in Betaflight, I would say probably the same for Flight 1 unless somebody has data that shows otherwise, offsets whatever so if the frames are coming in at 6 millisecond steps, meaning, they're like stair steps, and the tread on the stair step is 6 milliseconds apart, or it can be up to like 30 milliseconds apart. Whatever that stair step interval is, how far the tread is on the stair step, when you smooth it, your signals offset that far. So if you have 20 millisecond frames like a Spectrum DX6i, or 12 millisecond frames or 6 millisecond frames, that means whatever signals coming in, it's offset 6 milliseconds, because the smoothing's happening on the back side of the RC command. Now there's some information that using the filtering instead of interpolation, a filter method of smoothing, can negate some of that. Chris Thompson, CTZ Snooze, which really knows his stuff, has kind of told me and showed me about this, and he's a man of science. I'm gonna go. I haven't seen the data yet. I'm not quite convinced, but with the humps and stuff, it takes that out. But nevertheless, if you want zero delay, well, in Flight 1 you just turn smoothing off. In Betaflight, set it to interpolation, and then down at the bottom, instead of auto or manual, you can just turn it to off, and it turns off so your signal coming in your stepped signals won't be smoothed at all. For that, I highly suggest you cannot use feed forward at all. You have to have feed forward set to 0, or it's going to go bonkers with stair-stepped data. So you can try that. Like, I don't want delayed input. I don't want any of your filtering delay, guys. Cool, turn it off. But if you don't turn off feed forward, just be careful when you enter a roll. Don't do it near your body for a flight test. So that's possible. So that's, we're talking 6 milliseconds. We talked to Tyrannus or OpenTX doing a bunch of stuff. It's got to go across the air. We got another 6 milliseconds. Smoothing type as filter, not interpolation. This is under the receivers tab, and which filter is on by default. And you go into the command line and you type in RC underscore smoothing underscore info. I think it's info. If I got that wrong, guys, type it in the comment. I think it's RC underscore smoothing underscore info. That will tell you your frame rate. And take a look at that, because whatever that frame rate is, that's how much the signal is delayed for your stepped input. You can, like I said, turn off all that filtering and just turn feed forward to 0, and you can go try it that way, see if you like it. And some people might say, oh, it's a horrible idea. Now that we don't have set point weight anymore, and if you turn feed forward off, it's fine. You get jerky, your P-term stair steps, your D-term stair steps, because it has these adjust, but it flies fine. I've been flying it that way because I use that to line up black box logs. It will fly fine. It is definitely more, there's a little bit more of a twitch. Honestly, I could think you could go the other way though. You could just filter it like normal, like default, and just crank your feed forward up. You want more? I talked to eTracer one time, Bruce, about it, and he's like, feed forward goes up to 2,000. If you want it to be more responsive, set it to 2,000. It will be responsive. So that's another thing for feel. Just leave the filtering on like normal and just crank that feed forward. What we got here? Historic of stable over the last 3. The first baby, come to the kiss. And what's up, Mark? Thank you. Any other thing, beta? What's up with Betaflight 4.0? Well, there's lots up with Betaflight 4.0. Betaflight 4.0 is going to be a big release. Tons of filtering improvements. Launch mode. We got D-min, which is it suppresses the D term while you're not doing stick inputs. There's throttle linearization, which I guess I can go to some of this. So let's go through the major things I see. So 4.0. The dynamic filter, I have a video called Cascaded Low Pass, or Cascaded Dynamic Filter or something. It's like 2 or 3, maybe it's only 1 video back. So check that out. Basically, there's the dynamic filter actually has 2 notch filters separated by a gap. You can control that. So that's just another option, a variant. But more importantly, the dynamic filter since 3.5 has been how it tracks. CTZ and Ken Mitchell have done an amazing job at refining that, along with Bruce and Fusion's, AJ's assistance on, getting that to more accurately track and lock onto the peak noise. Because notch filters, based on what I've seen to date, have the most amount of attenuation for peak noise and the least amount of phase delay compared to a low pass filter. But they have to be able to track the peak. That's the key. If they can't track the peak, that effectiveness goes way down. So as long as they can track the peak well. So the next thing, then after we just about got that done, Joe Lucid came in and said, hey, I got this idea for RPM filters. Why don't we take the RPM data and use that to put the location where the notch filters. Instead of having 1 notch filter, let's have 4, 1 per each motor, and can track each motor independently. It's like, it's a great idea. First, the telemetry data was way too slow. I think it only updated like every 30 or 25 milliseconds. So Joe's worked with the BL Heli guys to get that down. It looked like it was down to 1 millisecond or less update rate. So that was awesome. Then he worked on his RPM code, and there's harmonics. I'll do a video on it. So RPM filters is the new thing. It shows a lot of promise. Honestly, I'm just starting to test it myself. I've been busy with other things. So that's on the filtering aspect. Then Chris Thompson, CTZ Snooze. Joe Lucid did as well, came up with an iteration, and CTZ worked on it. I think they combined together their code or whatnot, and that's what was merged, kind of ideas from both sides. From both of those guys, and it essentially suppresses your D term. I guess in the grand scheme of things, the D term is awesome for prop wash, but a total pain in the ass otherwise. The D term is the problem for everything. All this filtering mumbo jumbo, and it's because of the stinking D term, because of the way it works with, it works on the magnitude of the slope. So when you have that gyro signal moving up and down really fast, it amplifies the hell out of it. So CTZ and Joe were like, well, why don't we just suppress the D term, make the gains lower when we don't need it, and then when we do need it, we'll bump the gains back up. I was proposing like a D term boost, and they kind of reversed it and said, well, why don't we suppress it while we're not using it and have it just boost up to your normal PIDs when you need it. So they did that. So that's in Betaflight 4.0. So like when you do a sharp stick move, the D term before it kicks in is actually delayed. Oh, son of a... so it gives you more responsiveness because the D term actually fights, like I've said before, all gyro movement. Can I go through there? Okay, cool. So when you have a higher D term, it fights against you're entering a roll or a flip. Like when you go to stick right, the D term says, no, go back left, because it fights all gyro movement. So they've delayed it there, and then in prop wash, it can detect prop wash and then boost up. Now, it still has to, to detect something takes time. So you can try it out. I mean, I would think CTZ would agree. It doesn't help prop wash. It helps mid-throttle oscillations a ton, if you have those. If you don't have enough filtering and you want to use D-min, then that will help with getting rid of MTOs, because your D gains will be lower. If you, hold on a second here. Thanks. Yep. Sorry, security. So that's one. Throttle linearization is basically TPA, throttle point attenuation. Basically is when you go of the TPA breakpoint, which is in the PIDs tab, You can set that breakpoint at 1500, I think the default is now, and then anything above there, it starts to suppress your PIDs. Well, first in 4.0, you can change that so it's just the D term, not the P and the D. So D was mostly the problem, so why suppress the P term? Throttle linearization is kind of the same thing, except it boosts the PIDs at below 50% throttle and suppresses the PIDs above 50% throttle. The main point was boosting below 50% throttle because of the thrust your quad can generate is more like a curve like this. So at lower throttle, it has less control. So you need higher PIDs, is what it's off by default, but you can turn it on and play with that. I think it has a lot more benefit like for whoops and things of that nature. But like I said, I haven't really tested it that much, but that will be in there. It's off by default for now. D-min is on by default. And then the RPM filter stuff is, you'd have to do some things to get that set up. One of the things with the RPM filters, again, you need a 32-bit ESC, which is kind of the start of this whole live stream. And only certain flight controller boards can use it right now. They're trying to get that all worked out, so it's more universal, all flight control boards. And they're trying to get it worked out so that all ESCs, even BL Heli S ESCs. So I don't know if they'll be, I don't know where that will get between now and April. That's a whole month away. These guys move fast, so we'll see where it goes. But right now, there's a wiki. If you go to the Betaflight wiki page, there's a wiki on, RPM, the telemetry, the RPM notches. Go read that. It lists the flight controllers that it works with. You could test it yourself. Check it out. What else is new? Generic targets is new. I know they've been working on that for a long time. That's going to be a big deal. That's more on the program and maintenance side. I've messed with it a little bit, but I know the stuff I've messed with it to make the performance edition targets or hex files for F3 boards, which are out on my GitHub for Betaflight 4, like build 14 something, 1413 I think, 1409, something like that. I know in messing around with the code there, the targets are a lot simpler. They have like levels now, or features for F3 boards are kind of aggregated down. So I think it's going to make just long-term use for vendors and manufacturers and people that want to do some light code editing, make it easier to work with that. So that's a big thing. Throttle linearization, D-min, dynamic filters. What else am I missing? And I do have to get going. So triplet linear is not a problem. I'm trying to think of the thing I'm missing. RPM notches, nice little tune. Yeah, sugarcane, nice little tune on RPM notches, right? Some OSD elements, like a lot of the dynamic notch stuff is in the OSD. You got that FFT Max now on the OSD, which is in my cascading notch video. You can have, it looks like we're going to be able to have 3 profiles for OSD screens. So you can have like OSD profile number 1, OSD, so you can kind of switch, like if you're going to do a GPS day, or if you're going to use that quad for racing today, you know what I mean? So you can kind of turn different stuff on your OSD instead of, before it was just OSD on or off. Now it can be like, oh, I want to, have my GPS stuff on today, or switch into my GPS stuff during mid-flight. I don't know if that would be possible. They'd have to have a mode for that. I didn't see the mode yet. Trying to think of what else is in there. I mean, I know I'm missing stuff. There'll be a list, but there's Ken, list up here on the thing all the stuff I'm probably missing. But I think those are the big things. So, anyways, I'm at my spot now for I have a night meeting. So I got to hop. I hope this was helpful. I don't know. Figured I'd burn some time. But yeah, D-min. I was just talking about that. All right. Yeah, the default's on 4.0 or bi-quad, but the filter's up at 150 hertz or higher. But PT1 is still less phase delay. I'll do a video on that. So we're used to like our cutoffs for low passes being down like 100 hertz. First of all, they're going to be dynamic. Oh, I forgot about that. Dynamic low pass filters. Your low pass filters are going to be dynamic in 4.0 linked to the throttle. We're used to them being down at 100 hertz. That's way too low. So as the dynamic notch got more effective by all the good work of Ken and CTZ and all those other guys, George Hartman, all those guys, then we don't need as much low pass filters. So it was able to move those up. So the new norm to me, first of all, they're going to be dynamic. So actually, when you go up to 100% throttle, they're going to have to go up to like 500 hertz. They're going to go way, way up. But the new norm for the low value or the min value for the dynamic low pass filters is going to be like 150 to 200 hertz. So we have to leave the concept of 100 hertz behind. We're not going to need to be so low. And that's a good thing. Less phase delay. As the low pass filters are lower, they have more phase delay. So you want to try to bump those up as much as you can. Linking them to the throttle was a great idea, right? Because then when you're at low throttle and the vibrations are low, they're down lower. When you're at high throttle and the peak vibrations move up in the frequency spectrum, well, the filters just go up there with it. And as they go up higher, they reduce the amount of phase delay. And if you look at when you're hitting prop wash, you're usually above 50% throttle. So bingo, that's when you need phase delay to be the least amount. Okay, I do got to bounce. Thanks, guys. Hope this helps. Wow, this was kind of a long session. See ya.